All right, lesson two on air pollution is going to be about photochemical smog. And as seems to be a theme from the first lesson, this is another meme that's picturing India where there is uh, really bad air pollution. I can actually state that from experience. I've been to India a couple of times, and especially in Mumbai, which is the largest city in India, the air pollution was bad enough that every time I'd blow my nose, um, basically the mucus would be kind of blackish. So let's take a look at some of the important components of what are going to lead to photochemical smog. So one of the big things that can create photochemical smog, which is a secondary pollutant, is volatile organic compounds. So what a volatile organic compound is it's something that evaporates very easily at room temperature. That's going to release gases into the air, hence the connection to air pollution. So some of the examples, gasoline, formaldehyde, you see various ones on this graph. So xylene, toluene, propene, a lot of enes. And they have both anthropogenic sources as well as natural sources. And I am going to hammer this point home that anthropogenic means human caused. So humans cause the release of volatile organic compounds from things like paint, production of pharmaceutical drugs, so medications, refrigerants, various industrial solvents, some petroleum fuels like gasoline, etc., hydraulic fluids like what are used in hydraulic fracking, paint thinners, dry cleaning agents. There's a number of various things. So industrial emission, gasoline emission, diesel vehicular emission, and fuel evaporation are some major sources of VOCs. There's also biogenic emissions, which is actually a natural sources. So vegetation can also release some volatile organic compounds. So it's not all humans, but we put a lot more of it into the air than would naturally exist without us. And that's going to become important in a moment. Then there are various nitrogen oxides. Notice that they look like they're spelling out NOx, but that X just stands for any number of oxygens. You can have various chemical formulas with nitrogen bonding with different numbers of oxygens, as you can see from this diagram. So some of the nitrogen oxides or NOx's that are toxic to humans are NO, nitric oxide, and NO2, nitrogen dioxide, both of which are going to have negative health impacts on humans. And then one that's a greenhouse gas, and that's N2O. I know technically it's two nitrogens and not one or more oxygens, but we still kind of class it as a nitrogen oxide. So these are important because of their contribution to forming something called smog. Smog is a term that developed from a combination of the word smoke and fog, so it's kind of a compound word. And there are two different types, as you see in this diagram. And I apologize that it's grainy. It was kind of the best diagram that I could find. So, industrial smog was kind of the original stuff. It's the OG smog. It is basically formed from um, burning things in like factories, etc. It's also called gray air smog because it looks kind of gray in the air. So if you see, kind of movies set in like the 1800s in England, you'll see a lot of cloudiness in the air, and a lot of that is industrial smog because they were burning a lot of coal at that point. Photochemical smog is more nitrogen based instead of the sulfur based industrial smog. And it is called also brown air smog because it tends to create this kind of brown haze over cities. It is catalyzed by UV radiation. That means that ultraviolet radiation from the sun, which you see in this diagram here, is necessary to the formation of photochemical smog. And that's going to be a common theme that we talk about in this lesson. So what is photochemical smog? Like I said, it's kind of brown. So here's a picture showing a city with a nice hazy layer of smog over it. And it's made of a mixture of pollutants, secondary pollutants formed when NOx's and VOCs react together. And this reaction is powered by UV radiation. So that's that catalyzed by UV radiation, which is makes the chemical reaction happen. It's very common in urban areas because we have so many motor vehicles that it's going to create a large concentration of these NOxs and VOCs being released into the air. The highest levels tend to be during the summer because of the increase in solar radiation that's coming in. So there's more UV radiation, which causes an increase in the formation of photochemical smog. And it's got anthropogenic air pollutants, which is going to be mostly ozone, nitric acid, which can contribute to acid rain, and various organic compounds. So this series of reactions is the set of reactions that forms photochemical smog. So you have nitrogen oxides, like NO2 and NO. Then you also have oxygen interacting with these kind of oxygen atoms reacting with oxygen molecules. That forms ozone. Then, nitrogen oxide and ozone, well, so NO and O3 can make NO2, which can then kind of feed into that reaction. NO2 and various other compounds can produce something called PANs, which are peroxyacyl nitrates. And then you can also, this is just a series of reactions that can happen over and over. The big thing is going to be the ozone and the PANs. Those are the major chemicals that are going to be forming this photochemical smog. So sources of NOx's, car exhaust, coal power plants, factories release it into the air. Sources of VOCs, gasoline, some emissions from cars, paints, cleaning solvents. And when those react, because of being hit by UV light, providing them with energy, that is what's going to cause photochemical smog. So, what factors affect the formation of it? Well, like I said, cars release a lot of the chemicals that contribute to the formation of photochemical smog. So, the amount of automobile traffic is going to be important. This means that photochemical smog formation is going to be highest during things like rush hour traffic when there are more cars on the road, and also going to be greater where you have larger concentrations of vehicles, like large urban areas. If you're out in the countryside, you're not going to have a high enough concentration of these chemicals being released from cars and to create as much photochemical smog. And then the intensity of sunlight is important because the UV radiation is helping these reactions happen. So it's going to be the greatest problem of photochemical smog formation during the summer, especially in the afternoons when sunlight is more intense. So that means that the afternoon rush hour, more than the morning rush hour, is going to be when you have the most photochemical smog being produced. So, what are some of the environmental impacts? Well, sulfur dioxide, the nitrogen oxides, and ozone, as well as the peroxyacyl nitrates or PANs, can damage plant leaves when they enter through leaf pores, aka stomata. And then when you have long-term exposure to these pollutants, it can damage the plant cuticle, which is the waxy covering for plants. That waxy covering has a number of different functions, including reducing water loss, helping to protect from disease and pests, and also helping to protect from extreme weather conditions like drought and frost. So when you have a lot of photochemical smog in an area, it can be very damaging to local plant life. There are lots of human health impacts of photochemical smog as well. Obviously, since it's in the air, you breathe it in, that causes a number of respiratory problems. For example, it can mess with your lung function, cause breathing problems, coughing. This is especially dangerous for people with disorders that affect their ability to breathe, so asthma, bronchitis, and emphysema. And so people who have those diseases may have their symptoms be exaggerated or aggravated by exposure to photochemical smog. So, you may have somebody with asthma develop an asthma attack, somebody with emphysema have more trouble breathing. And heart disease is also a factor that will also be aggravated by photochemical smog. There's also irritation to everything that gets exposed to air, especially with some vulnerable surfaces, so your eyes, your nose, your throat. It can compromise the immune system, which means there's going to be more sickness as well. So, because of this, you'll often have these air quality alerts. You'll see them most often during the summer on these boards. You'll see something like an orange air pollution watch. What that is going according to this scale. So, orange, for example, means that the air is unhealthy for sensitive groups. So, those people should stay indoors when possible, especially in the afternoon. So it says, for example, here, schedule outdoor activities in the morning when ozone is lower. Remember, the ozone levels, which are, one of the secondary pollutants produced as photochemical smog, that is going to be at its highest levels when there's a lot of sunlight and a lot of cars. So when you see an orange alert, don't go for a joyride. Try and reduce use of cars, and try to stay indoors, especially if you have lung problems, asthma, or people who are older, children, teenagers, etc. I have not really seen any red ozone days for us. Um, However, when it's a red ozone day, everybody has to be concerned and try to limit outdoor activity in the afternoons. So how do we reduce photochemical smog? Well, one thing that's been important in that is enacting laws that are going to monitor and regulate what chemicals can be released from factories into the air or what times they can be released. So instead of releasing them in the afternoon, make sure they're released at night or during cooler times when there's no direct sunlight. There's a lot of things that deal with cars, so decreasing automobile emissions. One thing is you'll see when there's an orange alert, the signs on the highway will say car like ride share or carpool, and that's to encourage there to be less cars on the road. You can also encourage the use of mass transportation as well. Another thing is if cars are well maintained, that can help reduce emissions by improving your gas mileage. So, making sure your tires are properly inflated, that your oil gets changed regularly. If more people pump gas during the night or the early morning, every time you pump gas, you know how you can smell the gas in the air? That's because there are VOCs being released. So, this would help with VOC release. And remember, you need VOCs and nitrogen oxides. In order to make photochemical smog. So if you can reduce the amount of either of those, then you can decrease the formation of photochemical smog. Then avoid products that release VOCs. Like there are products that you can buy that are specifically branded as being low VOC, like low VOC paints. And then instead of using like gas-powered lawn equipment, like lawnmowers or weed eaters, etc., you can use electric versions as well. All right, there is photochemical smog. Our next lesson is going to be on temperature inversions.